Glad everyone could be here and I could help talk about this some more. I hope you've been hearing about it, but if not, we're really excited to be putting this out there. And really, the goal is to get feedback and engagement and make this a collaborative process for our architecture. So, next slide. So the reason, one of the first questions we need to answer if we're deciding what we're going to do is why we're doing it. And really the goal here, this is, we've been calling it Pam's chart, but it's the why, or why do we explore, and especially with humans. And it's really all three of these reasons. So science is front and center. It's one of our most important things, but we also do this for other reasons, including economics, technology, and the inspiration that comes with it. So all of these are drivers in deciding what we're going to do, how we're going to do it, and the rest of the questions that you have to answer to solve the architecture. Next slide. Last year, there was a tremendous effort put in, including feedback from the community on NASA's Moon to Mars objectives. So these were broken into four categories: science, transportation, habitation, lunar and Mars infrastructure and operations. This process was iterated on last year, which is really setting the long-term vision. What do we really want to do over many years in terms of exploring the moon, centered around the human exploration, but not limited to the human exploration of the moon and Mars. So these objectives were laid out there. And then really when we're talking about the architecture, it's the what comes next. And so that's what I'm going to talk about. So if we take these as our long-term goals, they're very big, very lofty. And then how do we actually implement these? So that's what I'm going to talk about. In terms of the goals, these got feedback, or the objectives, from the NASA workforce internally, as well as international partners, but also US industry, academia, and other government agencies, among many. The feedback process was really open to everyone. And so these are really setting a long-term vision. Next slide. So in terms of setting that long-term vision, the phrase we've been calling this is essentially architecting from the right. If we understand the long-term goals and objectives, that's the blue box, that's that strategy document and all those objectives, we actually start from there and decompose it or break it down into the executable pieces that we need to build up to get there. And that way we can trace all of our systems, all of the missions into how they're actually helping lead to accomplishing those goals. So the goals themselves are very esoteric. Some of them, one of the science ones is uncover the record of the solar system. But in terms of what we, in terms of the engineering teams and the science community, need to actually implement, we translated those into the characteristics and needs. So for many, simply returning lunar samples is the physical action that needs to occur to support some of those objectives. Some of them, like transportation systems, are much more relatable, right? We actually just, the objective is the system that can carry the humans. So, but in either case, we attributed characteristics and needs to all of the objectives. And then from there, you can actually break them down into the use cases and functions necessary in the elements of the architecture to accomplish them. So for our terms, use case is really the operations. You can think of it like the concept of operations or the actions that need to occur of many systems together. And the functions are the actions of any individual element, such as actually collecting a sample or being able to transport the crew. Those are the actions that the elements need to contribute to the operation. So we've grouped all of these, and as we break these things down, we can then relate the function of an element to the requirements, and then how all of those pieces fit together to execute the objectives. So this is a long-term process. We've only essentially filled in some of the earlier parts of the architecture, and we have a lot to go. So this is an ongoing process that we'll iterate on every year and build out more and more features, more and more elements to meet the objectives. So we can go to the next slide. So as an example of this decomposition, I used the transportation and habitation one, which is transporting the crew safely from Earth to the lunar surface and lunar orbit. So the needs, the characteristics and needs are shown there. And then these, as you keep working from right to left, we can actually attribute which functions an element has to contribute to the architecture. And then in purple, which element supplies it. So for example, transporting, we'll take the third one down, transporting elements from Earth to cislunar space and docking those elements together are the functions. The operation is physical assembly. It's that mating, it's the assembly of all of these pieces in space, and those pieces are attributed to the Space Launch System, Orion, and Gateway. So this is an example that's fairly obvious, but that way it's easy to relate to. Some functions and objectives are much more esoteric, and we've broken it down into how do we accomplish it this way. But this is an example of how you go from a high level objective into the elements that we need to trace all the way from the policy to the elements implementing the architecture. This first round of essentially architecture definition was creating the process and developing the human lunar return segment. So if you go to the next slide, that's our first set of needs to get back to the moon. So if we take the long-term goal and break it into 4 segments, these are increasingly capable segments, increasingly capable operations. The first one is simply establishing that initial return to cislunar space, the surface of the moon, the initial science and technology needs that accompany it. So all of that is getting there and putting our footprints back on the moon to have the capabilities to expand from. Foundational exploration is really where we want to have the systems and the capabilities, really the operations, to get to the 4 crew, 30 days on the surface, multi-month in orbit type of operations. So putting all of those things together to expand the exploration footprint, the greater science content, all of the additional systems like mobility to have all of those capabilities, and then to continue evolving from there. So sustained lunar exploration is where we want to build out long-term infrastructure and start demonstrating the systems, the mission links needed, all of the human research to help get to Mars, and then eventually onto Mars. So this first one, we focused on the human lunar return, and ACR is our architecture concept review. 22 was for our year 2022 analysis that led to it. This year, we're trying to finish that decomposition and fill out the Mars level of the segment. The objectives, it's really, what are the functions and use cases and some of that initial analysis. It's not making decisions for all of those future Mars systems yet, but a lot of Mars content will be added this year. So the segments is how we are breaking out the operations to grow over time. The sub-architectures are really, if you think of a system and subsystems, the same type of thing. There's a lot of elements that are tightly coupled, like communication and navigation. That's going to be one set of systems that all have to work together, whether it's orbital relays, ground infrastructure on Earth, the radios on the vehicles. So making sure all of those pieces work together within the larger architecture. So that's just to help us keep track of what's going on, make sure we can find gaps between elements and systems, and each part of our architecture needs to be responsive and capable to support all of the other parts. Next slide. All of this was published, and the QR code will take you to a website that we're actually actively filling out and adding to over time. The first document is the architecture definition document. It's about 150 pages. It's a highly technical volume. And as I mentioned, this document will be updated yearly as we add elements to the architecture and continue to work and collaborate on how NASA is going to achieve these objectives. The summary in the green is a great place to start. It's a high-level description of what you'll find in the ADD, but in a nicer, 15-page glossy format. And then the other piece that we're adding to the architecture documentation are white papers. So we dropped 6 papers to start, but these are really answers to what was the trade and the underlying engineering that's driving some of our architecture decisions. So why are we in our NRHO, the near rectilinear halo orbit, is a frequently asked question. We've documented some of that studies, the engineering rationale in about a 4-page document to make it accessible to the general public. Next slide. And then we're also working on engagement and feedback. So anytime you're meeting with NASA or the stakeholders, whether it's SMD team members or the exploration systems team members, we hope this becomes an ongoing dialogue and process. So anytime there's engagements, conferences, things like that, like here today, we welcome feedback on it. We're also planning a NASA workshop in the US on the 27th and 28th of June, geared toward more feedback through small group discussions with commercial and academia partners from the US. It will be in the greater DC area. Information to engage and register for will apply to be in, because we can't take everyone, will be on their website as well. So I just encourage you to use this as a way to communicate with our partners and the Exploration Systems team and our science community as well, because the objectives were developed by our science partners, and we're working to support this as a whole agency. Next slide. And just to wrap it up again, this is the QR code that takes you to the website where you'll find all of this information in greater detail. And thank you. Look forward to working with everyone on this process moving forward.
Thank you, Nujoud. It's great to see that all that information consolidated in one place for the community to be able to look at.